Introduction to Relief System. System protection contains three levels. Primary protection, which is control system. Secondary protection, which is hardwire tree protection. Tertiary protection, which is contains safety valve, rupture disc, and flare system. Here we are going to talk about flare system. Any refinery and petrochemical facility utilize flare as a vital safety mechanism. These devices securely burn any hydrocarbon gases that cannot be recovered or recycled in the system. By utilizing flare system, excess hydrocarbon gases are safely and environmentally disposed rather than being released directly into the atmosphere. It should be mentioned that the CO2 as a product of burning hydrocarbon is 25 times less harmful than hydrocarbon. In general, PFT of flare system contain flare header, knockout drum, blowdown drum, water seal drum, and flare stack. Knockout drum. The flare header bring flammable gases from the process unit to the flare system. These can be continuous or in the intermediate process. The gas flowing to the flare often contain liquid, particularly during the emergency blowdown. If liquid are allowed to flow up the flare system, they will catch a fire and come down as a burning rain, creating a very hazardous situation around the base of the flare. Liquid could also extinguish the flame or cause irregular combustion and smoking. Therefore, there is generally a knockout drum or pot at the base of the flare. The liquid are collected and pumped back into the process. About the burning rain, it is important that the liquid do not accumulate in the flare header itself. Otherwise, liquid slug could be formed that, when traveling down the header, could lead to the header being displaced from the pipe rack. For the same reason, the number of bends in the flare header should be minimized. One of the ways to preventing a buildup of liquid is to have a flare header slope gently downhill toward the knockout drum. As per API 520, the minimum slope should be 1 over 450. Blowdown drum. Blowdown drum has the same purpose of knockout drum. If the amount of liquid in the system is low, then knockout drum is sufficient. Otherwise, blowdown drum also may require. Blowdown drum usually installed near the sources in battery limit of the unit to reduce the amount of piping. Seal drum. The function of seal drum is to prevent backflow of the gas from the flare stack to the flare header. It is essential that the oxygen not allowed to be entered to the header because it could create explosive mixture. The drum achieve this goal in two ways. First, the flare gases enter the drum and immerse into the liquid seal, which is water and glycol. Second, a small and continuous paired gas flow is added to the drum that ensure uh, there will always be a forward flow of gas to the flare. Seal drum is installed at the base of the flare stack. Flare stack. Depending on the quality of the gas that is being burned in the flare, it may be necessary to inject air at the base of the stack. Near the top of the flare is a flashback prevention device, which is a molecular seal or velocity seal. It is critical that this device not plugged with the solid, otherwise the flare system could not be worked. Also at the top of the flare is a pilot flame that burns continuously. It will have its own dedicated supply of fuel, gas, and air, along with the sparkling ignition device. Because it is important to keep the gas stream turbulent, so as to minimize smoke formation, steam or air can be added to improve the combustion quality. Molecular seal and velocity seal. Molecular seal below the flare tip stop air from getting into the system and causing explosion. It uses a gas inversion device to change the direction of the gas flow. Heavier gas settle in the lower band and lighter gas collect in the upper band, creating a seal. To prevent air from entering, a small amount of purge gas continuously blow to the molecular seal. Velocity seal has the same purpose, prevent air from entering the flare tip by using a cone-shaped pipe to redirect the air away from the inner wall. The purge gas flow sweep away the air, reducing the purge gas velocity through the tip. In general, velocity seal has the lowest capital cost, molecular seal has the lowest operating cost. Typically, there is two types of flare. Elevated flare, which position the flare tip at the height ranging from 20 to 150 meters above the ground. Ground flare, which position the flare tip at the height of approximately 2 or 3 meters above the ground. These flares are surrounded by a high heat shield fencing, which double as a safety zone. There's two types of ground flare and enclosed ground flare. For elevated flare, which is most common flare in the industry, there is three types of structure. Self-support structure, um, which is used for the low height stack between 60 to 75 meter, and it needs less space for installation. Guide support structure, which has a cable hold up the flare burner and limit the riser deflection. Used for high height flare stack up to 150 meter. Their installation required a wide area. Fixed derrick support structure required to limit the radiation on the ground, and also when there is a limited amount of area is available. Used for very high flare stack over 200 meter. There is a combination of guide support and derrick fix support structure, which is derrick guide wire structure, which are good for installing flare package when there is a large clearance area and a need for supporting riser system. There's different flare tips. Flare tip. The most common one is open pipe flare tip. The open pipe flare tip is a simple and reliable design with a cylindrical fabrication and a flange that connect to the flare riser pipe. It is used where smoke is allowed or the gas it doesn't produce smoke by itself. Even though it's possible to add steam or water inject to reduce the smoke and reduce the thermal radiation. Air-assisted flare tip. Air-assisted flare tip achieve a clean combustion by injecting primary air into the base of the flame with the electric fan. This design split the gas stream into a smaller stream to increase the gas-air contact surface area and promote the mixing. Air and gas are routed separately to the top of the flare to ensure the safety of the process. Multi-point flare use multiple small burner for better combustion and reduce smoke and radiation. They are commonly used in a high-pressure flare application and have a pilot made a heat-resistant steel and also an igniter. Quantum flare tip. The quantum effect refers to the tendency of the fluid, such as gas or liquid, to flow a curved surface rather than continuous in a straight path. Quantum burner use this effect to work better. They have a tulip shaped tip and high pressure gas flow around, while the low pressure gas flow in the middle. This make less smoke easier to light and lower radiation level. But it need high pressure gas and only work within a certain range. They also produce much more noise than other tip. High velocity tip. The use of very high and sonic velocity gas at the flare tip improve air entrainment compared to the other pipe flare tip. The use of multiple jet and the low pressure jet ensure the stabilizing of the flame under this high velocity tip. The improved air entrainment as a result of the turbulence in the high velocity gas reduce smoke formation and also thermal radiation. Flare pilot burner and pilot igniter. As per EPA regulation, the continuous flame on the flare is required, which is provided by continuous pilot burner positioning around the flare tip. Igniter are used to ignite the pilot. Most flare tip have at least three pilots equipped with the windshield, and also various type of igniter are available based on the vendor. The most common one is a flame front ignition and electric igniter. Flame front ignition is a gas mixture of gas and air is introduced at the ground level and ignited by spark, which travel up to the top of the flare to ignite the pilot burner and all other pilots. Electric igniter uh, is provide automatic reignition and pilot monitoring for flare. They eliminate the need for the traditional flame front igniter and use a spark to ignite the pilot nozzle. These ignitors are available for manual or automatic operation. Thank you for listening.